like you're Tom Cruise, and then your PPT shows up, you're like, okay, fall flat. So yeah, so I am Neelamani Gupta. You can call me Neel. I work with Gojek in their data domain, um, data science, analytics. Right now, I'm looking at data governance. Hey, you don't get access, you don't get access, and all of that. So let's start. And I'm really excited. And some of the speakers have already talked about ROI. I think the gentleman just before me talked about ROI solutions for data science. And I think in one of the previous talks also there was concerns around costs of LLMs and whether we go chat GPT way or open source way. So as you see, these concerns are always there. But this is a tech talk, I know. This is a tech conference, but I'm going to talk more about finance maybe, because that is what we've been trying to focus hard in the last 2 years. That what are we building? Are the things going rogue, or are we able to generate enough business returns? And can we build a culture where we are aware about business returns? Right? We know that we are techies, core techies. Gojek has a very strong tech DNA. We believe in creating new things, but it's very important to be aware. We put so much love in our technical solutions, but as you know, as we say that eventually things have to produce returns. So let's quickly go to the next slide. And why are we even talking about returns or ROI, right? So if you see on the first, I'll use this maybe, yeah. So if you see here, it's a simple keyword search AI, how it has kind of gone up. So general public is interested in AI, people are searching, want to learn. That graph there shows how many times AI has been spelled out in earnings calls, where CEOs come and talk about how much their company has earned, etc., etc. And you can see that CEOs and CXOs are talking about AI more and more, which means that there is business around AI. And the last is, they're not just talking about it, they're investing hard money. They're going to invest a lot of money in the next few years. They have been investing, and they're going to invest. What does that mean? That means that there are no free lunches, right? Every money that gets put in eventually has to return, right? Has to give some returns. And so there are some expectations. And why are we talking about this? Are there concerns around this? Yes, there are concerns around it. There are plethora of examples in literature where you'll see, top AI heads, CEOs sharing concerns about we are not getting enough returns from our AI investments. Like this bottom line, if I have to read, a mere 10% of organizations achieve significant financial benefits with AI. I'm not saying that everywhere AI is not giving returns, but there are genuine concerns, and that is how it is. When you take bets, you lose some. That's how it is. Now, why is it important for us as data scientists, right? Whenever AI doesn't generate return, or whenever there is a question on returns on AI, data teams and data leaders are going to be on the spotlight, right? They will have to face the music and answer the questions. And again, plethora of examples where a lot of, there has been a lot of direct attack on CDOs, data teams saying that, hey, you guys are not returning. And if I have to read here, Gartner's report says 69% of data analytics leaders are struggling to deliver measurable ROI. So the question is there no ROI, or is this something else? And that's where we started looking at, okay, are we not able to deliver ROI, or there is something else? So what we found was that there are mainly two reasons. One is that you've taken a bet and it has not worked. That is fine. We take a punch on our face and we say, okay, it didn't work. But a lot of times, and astonishingly, what we have found is that it's not a problem that it is not working. It's that we don't know it's working. It's a measurement and communication problem. Data teams are not skilled and don't have a culture of measuring returns properly. They don't spend enough time on it, right? Sometimes you have product and business folks to kind of force you to think like that, but most of the times it doesn't happen, right? And that is the topic of today, that how can we get a playbook or a framework to measure these returns for our solutions, right? And how can we make it a culture for us, right? So there's no rocket science here. I'll quickly walk through. Simply put, figure out what are benefits that your project gives, ROI solution gives, what are the costs it incurs. Cost is something which I've seen very, very, very few people looking at when they build AI solutions. Very few. But in the new LLM space, costs are going to be very important. LLMs are costly, right? Even serving and doing dot predict on LLM will just burn a hole in your pocket if you do it like many times a day. So the idea is, what are the benefits? What types of benefits? How do we measure them? What are the costs? How do we measure the costs? And how can we optimize those costs, right? So let's get going. And then yes, obviously being proactive about the ROE evaluation, do it for every project, build it as a culture. It took us almost 1.5 years to do this at Gojek, right? And now I'm very proud to say that each of our team members knows how much GB costs how much, what compute costs how much, and even before we start, we are able to estimate, okay, what is the cost we are looking. So I remember when every time I had to like fill the budget sheet of infra, I would just do 10% extra and fill. But that is not anymore. We can actually calculate estimate costs and say, okay, this is what we want for the budget next year, right? So yeah, this click doesn't work. So I'll just keep doing this jumping around. So yeah, very simple. Return on investment, you calculate benefits, costs, types, how to measure. And one thing extra for costs is, once you know the costs, you know where to optimize. And that is the challenge, right? Quickly jumping into benefits. So when I talk about benefits, think about any AI project that you do, right? So an AI project would always have either a hard benefit, it's a very loosely used term, which means that your project is directly related to a benefit which is easy to measure, and to say is closer to money, right? While there are certain softer benefits, right? Let me just quickly. So harder benefits would be like for example, you are building a recommendation engine which will cross sell on your website or app, and it will generate more revenue, easy to measure. I know this thing is directly related to revenue, easy to measure the benefits. Discount targeting, dynamic pricing is a great example where we want to kind of make more money. Time savings, you have shortcuts on the app, you can quickly jump to another place, so you know that you're saving time for the consumer or the user, right? So it's also a very direct kind of a benefit. Cost savings, plethora of examples, route optimizations, a lot of NLP is used to intent detect and then make sure that we can answer customer support tickets rather than solving them, eyeballing them. That saves costs. Productivity increases. You rank your leads for your sales team. They know which leads to go after immediately. That's productivity increase. You create a model which summarizes documentation, SOPs for your agents. That is a productivity increase. So here you can easily measure what the benefit is and probably come to a dollar value sooner than soft measurement. Soft measurement is like better experience. So when you go on the app, the color changes. It identifies, hey, you're a customer who likes lively colors, and lively colors come up, right? You really don't know what the dollar value is, right? At least in the short term. It takes some time to figure out, okay, whether the customer sticks on because of this, and I'm generating value. A lot of these things you do it for parity. Because your competitor is doing it, you have to do it, right? So a lot of these things could be because of parity. Then migrations. Our engineering teams are always into migrations, which is required because you need to go to the new tech, and you might not be able to immediately tell what is the benefit out of it. And then the last point, which is my favorite point, is agility and skill retention. And it's very important. If you're not working on the latest tech, your teams will leave you, because good people will leave you because they want to work on new things. So you need to figure out ways to balance this out, right? And that is where the last point is, that all of your projects cannot lie in that top bracket, and all of your projects cannot lie in your soft bracket. You as a data leader will have to figure out the right balance, that how much of your bandwidth will go into aspirational projects where you are learning the new tech, doing something which you really don't know what returns would be, But in the meantime, you still have to run your house, right? So you have to have projects which have direct benefits, right? So in this entire talk, this is one of the most critical part, right? That how do we measure benefits? And I've found even we found ourselves to be lacking, like maybe a year or 2 years ago, that we were focused too much on technical metrics. So let me go there. So the first is to identify the right set of metrics to go after. Like, what are you going to measure, right? And the second is obviously measure them. And what are the nuances of measurement? So technical metrics, we all love them. We all love to talk about precision, recall, F1, MRR. Great, we need them. There is no question about it. If you're starting to build a model or an AI solution, you need them. You need them to find out, hey, how does my model work on previous data? Because you can't go live. You can't test it on real data, real-time data. So you have to have metrics which can basically identify which models are working better. Are they even learning something? But this is hygiene. This is something you have to do for your models. It doesn't tell you whether it will create business impact. It only tells you that among these 5 models, this is the best learner and probably give you the best result or output or best dot predict, right? So, and for us data scientists, now I think it is imperative to look beyond technical metrics to convince, or at least to know ourselves whether we are producing business output or not. So go beyond technical metrics and look at input and output metrics. I mean, there's a lot of English there. Anything closer to money is an output metric for me, right? So, a lot of people would say CTR, drop off. If people are dropping off, users are dropping off, that's a metric to follow. Yes, great, but people drop off anyways, right? Your model, is it creating more value? People are clicking on your recommendation, but are they even booking? They are clicking, yes, great, but the model is great, prediction is great, no business value, right? So find a metric which is closer to money. Very simple. How do we find it? Ask your stakeholders. Somebody would have come to you to say, hey, build this for me. Why? Ask that why. Why are you asking this? Because a lot of times they would know what they want to optimize. They would know the business KPIs. The newspaper cuttings that I showed you, that had very clear, a survey said that CDOs or data leaders who are able to understand business KPIs were 1.7 times better in terms of taking their systems to production. Because they know what will immediately get approved, right? So let's take an example, because this is the most critical part of identifying the right metric. So let me take an example, and I'm using Uber screenshot. So on the right side, you would see that when you open the Uber app, it will show you two addresses to go to. Maybe you have gone to like 100 addresses, but it only shows 2. So let's say somebody comes and says, hey, build me a recommendation model or a ranking system which will rank the 2 best addresses, right? For me on this page. What metrics would you want to do or want to take? Anybody who's still following wants to call out a metric, please raise your hand. What do you think if you're a data scientist and somebody says, hey, build me a ranking system for this? What metric would you use to identify whether your model is good or not? Number of times you have clicked, which is like click-through rate. Like, let's say 100 people land on this page, how many actually click and go forward on this, right? While the others would type, right? So that is one metric, which means that it is amazing that your model works in terms of predicting a good value, right? But doesn't mean that the guy is booking more. He's going to the next page and just dropping off. So that's why what we need to see is wherever our model is going to interact with the user, that is not just the place we have to look. We have to look beyond that. Now, if I would have told you that this is the page, after this the user goes here, and after this the user goes here, and only when he clicks this black button, then you get an order. Otherwise, you don't. Otherwise, all of this is like window shopping, right? So now I know that, boss, CTR will only take me here. It will not give me more orders. So what I would do is I would test the entire funnel. when I go live with my experiment, I would see that how many, obviously CTR is important. Why? Because it tells me that what I'm recommending makes sense. Is it making more money? That you'll come to know from here. Then you say, okay, 50% of my users, I will treat them with this new model and see how many of them book. Is that booking rate more than if I don't show them this? And then you know that you're generating more value, right? In terms of money. Otherwise, consumer experience, yes, great. So, and that is where the next part is. Like, it is very important to know what metric you want to measure, and it is equally important to measure it correctly, right? And I'm going to, I want to look at the clock. Oh, we have time, awesome. So, so two dimensions, time and space. When you measure in time and space, which means that for your metric, measure what happened in the past. Had your model been deployed in the past, what returns would have it generated? Then you go real-time testing, right? And then you go continuous testing. What is continuous testing? Like in Gojek, we have a lot of models where a 5% control set always lives, so that we can always figure out how much money we are making from this model, right? If this model doesn't exist, then how much do we lose, right? So time dimension is very important. You have to test in the past, you have to test in the present, and you have to continuously test in the future as well to make sure that it is generating value. It's not, so continuous testing is not required for all of them, all projects, but there would be projects which will require this. And the last is space, and this is the point that I mentioned in the previous slide, that the point where your model generates or interacts with the user maybe is not sufficient. You have to look beyond that, or maybe before that, and figure out the right funnel you want to test, right? The entire user flow that you want to test, and not in silos. You can't do that, because that will not generate value. You will not be able to assess value. And this is time and space dimension, and then you deploy the right tools to measure, right? I think experimentation, I have a 100-slide deck on it, like it's a topic in itself. How do we experiment well? How do we measure well? Do we do A/B test normally? Do we have to do synthetic control, switch? It's a study in itself. But you need to deploy them. And then only you are able to figure out, then only you can figure out whether you're creating value or not, right? So this is what I wanted to talk about benefits. So most important thing is identify benefits or KPIs closer to money. Yeah. Now let's jump to the costs, right? So we've seen benefits, how to measure. Now how do we measure costs, right? It's still straightforward. It's not very difficult, just that we don't do it, right? So again, type of costs, how to measure them, and then eventually how to optimize them, right? So AI costs, basically, okay, I'll forget the transition. So basically 3 types of costs. Infrastructure, most important cost is infrastructure, most important in terms of compute and storage. So any AI model that you have will have these costs. 100% will have these costs. Human resources, yes, I mean, obviously we are working, somebody is paying our salaries, so human resource cost is important, but you don't have to do it for project level. I think service companies will have to do it. Product companies would probably do it at a portfolio level. Your data leader in the organization would probably do that. And then data costs. This is like other data costs. Maybe you're hiring a consultant, taking some expertise, or you are actually buying data, or you are calling ChatGPT, right? So, or you're buying weather data, or you're buying market intelligence data. A lot of companies do that, right? And so those things are important. So when your model is consuming all of those data, then you know that those are costs, right? How do we calculate costs? As I said, it's very, very simple, not very difficult. You just scan the project. And I think the best way to start is the architectural diagram. Basically, how routing happens, what are you using, what your system is interacting with. That is the best way to start, to understand, to list all the components it is using, where it is computing, where it is querying, where it is storing. All of that is in your architectural diagram. So you start from there, right? List down everything. List down everything. Like an old, if I have to say Munshi, like, list down everything. Whatever cost you think like. Broadly, compute. So whenever you query, it's a compute cost. instance. So, you to.predict, some computer is trying to process, that's the cost, and storage. We forget storage cost. And we found in one of our projects that storage cost sometimes is huge. All the experiments we do, all the logs that it generates is just too much, right? So, and then finally the API calls, where I said, you are pulling data from, let's say, some weather API, or Google API, or ChatGPT API. So you're calling it, and that is the cost. So these are the list of components generally would cover everything. Every component of cost would be associated with a pricing metric on which you'll get charged. So for example, when you query, you get charged on the GBs you are querying, right? When you store, you get charged on GBs you are storing. On compute is different. Compute is how powerful the machine is and how frequently you are using it, right? So compute is slightly difficult to kind of calculate immediately, but there are calculators that are available, or your engineering teams will help you, or your DevOps teams will help you do that. So once you and licenses will have different kind of costing scheme, right? They will have maybe requests per minute, per second. ChatGPT, I think, uses tokens, right? Tokens, how many tokens you want. Also the amount of tokens that can come back, how lengthy answer you want. So there could be tokens. And once you have this, then you can figure out what is the price of each of this. And it's fairly simple, honestly. It's very simple to find the price. Just go to the engineering team, they would know, because they manage it. Just that we've not talked to them ever. At least we found that, right? And I'll show you an example in the next page. Once we know the actual consumption, so you know the metric, then you figure out what is the actual consumption. Actual consumption is, let's say your model, you run it for one month, and then you calculate all of this. How many GBs it is storing, how many processing power it is using, how many query does it, querying it is doing every time. So on a month basis, this is the total amount of components that basically get consumed. You just multiply by price, you get the cost, and you add them up. And as I said, this is a screenshot from Google. So I have not shown the prices because it will show you Gojek prices. But you just scroll down and you'll get all the prices for all the components that I mentioned. It's very simple. It's just available. But as I said, we don't do it. And this was surprising. And this is exactly what we do at Gojek. Every project has this sheet where we are saying that, hey, for a project, what is the infra type? What is the cost type, compute? How many times it is getting used? Once every day, and then obviously some cost to it. And you can see BigQuery. It is consuming 96 GB per run, 2.9 TB monthly, and all of that. So all of this is possible. Now the question is, why are we doing this, right? A lot of times you'll find that probably your AI solutions are not that costly in terms of running. But being aware is very important, because only when you know that your system costs, let's say, $5,000 a month, then your brain starts working, okay, can I do it $200 a month? Before that, you are just not aware about it. You're just trying to build new stuff, you're trying to innovate, which is great. I'm not saying it is not great, but being aware is very important. And that is where, once you know how your models are running and what they cost. So for example, when I said, there were a lot of experiment logs that were getting generated, and they were just stored like this, like normal BQ storage, which has a certain cost. And we'll figure out that, hey, we never use all of them. We only need the last 30 days. So just partition the data. Save everything in GCS bucket, which is like 1/4 of the cost maybe. Whenever you need it, you retrieve. And on the normal high cost storage, you just store like last 30 days. It's a simple thing, one day implementation, you save costs, right? So only when we did this, we realized that, hey, we are just burning money. And how do you optimize these costs? Now, once you have these costs, how do you know that, okay, if this a particular cost element is too huge, how do I reduce it? How do I reduce it, right? So there are two broad approaches. I'll quickly just open up all the slides so there are basically broadly two approaches, a data science approach and an engineering approach. What does a data science approach mean here is where you are tinkering with what data scientists build, like models, pipelines, queries, right? So what you're trying to do is, hey, if my model is too costly or too heavy or it consumes a lot of data, can I simplify the model a bit, right? So a typical cost versus accuracy trade-off, right? So if I want to reduce the cost of kind of serving the model, hosting it, then one of the ways is to simplify it, right? So the model is not large, and we have done this. We wanted to deploy a solution on phone, and we had to do it in 2 MB. It was a computer vision model, and we had to bring down the layers of neural network because we couldn't get 5 MB or 10 MB space. So that's the cost versus accuracy trade-off. So you have to meet those things. So you can reduce model complexity, right? You can reduce real-time features, and this is very strange what I'm saying, but we figured out that for certain features we were doing so much effort to get them available real time, while we can just do it overnight. We can just ask somebody to run a job overnight, have those features ready, because we don't really need them real time. So we save on compute a lot, and accuracy doesn't like dramatically decrease. So, but all of these started coming to our mind because we were seeing a cost element that was too high. Feature complexity. Sometimes we just create too many features. Just drop the long tail. You don't need to keep the long tail, right? And then consolidation. This is a very important play where we are saying that, hey, platform play, where, to give you an example, when we tried to use LLM, we did not use it just for chatbot. We said, hey, can it serve more use cases for me, right? Because just a chatbot use case is just 2 or 3% of my chat flow, right? Or 2% of our users come and type free text. So deploying an LLM for that doesn't make sense. Can I consolidate more use cases under it? Then only it makes business sense to kind of use that model. I think somebody also mentioned it some time ago. So yeah, single model, multiple use cases, common pipeline. So we do a lot of common pipelining where, for example, for forecasting, maybe multiple forecasts are getting generated across our company, but we try to use common pipelines. We don't want to create new pipelines for new use cases, right? It requires effort because creating a new pipeline is easy, right? But trying to find an old pipeline that can serve you is difficult. You have, like, it's painful. You have to find somebody who will tell you what this pipeline does, whether it suits you or not. So it's a culture that you have to slowly build. Good documentation, really great discovery of what things you have built and reuse them. Transfer learning, yeah, I mean, that is, maybe use models which are already trained, use transfer learning. And the second approach, standard approach, is engineering approach, where you say, hey boss, I need to optimize my computer. I need to have auto scaling. I need to, like, monitor it every time. And these are like engineering approaches. Data efficiency, I just explained that, optimize storage. We were just unnecessarily storing too much data that was required. And we said, okay, let's partition. So all those things, pipeline optimization, right? All those things start coming to your mind because you have now focusing on costs, right? Once you have this and once you have benefits, for each model you actually have a P&L kind of a thing, right? What net benefit that model is giving. What it helps is it gives us confidence as data teams. I remember 1 year ago, my manager told me that, hey, this team probably is not doing great. Can we look closely what they're doing? And we looked there, and for 15-20 days, I think for 1 month, we ran some experiments, and we found that was a 3-member data science team producing almost $200,000 of savings in costs, and nobody knew about it. Nobody knew about it. Just because we were not evangelizing enough, we were not showing it that, hey, we are saving money. So once you start, and then what happened is, and once we revealed that, every town hall they were getting called, show their product, show what they build, and immediately everybody was like, oh, this team is doing great. So it gives confidence to you as a leader that, and as a data scientist, that you are generating value for the system, right? And yeah, that's more than what I wanted to say today. But in conclusion, I think it's important for data scientists to be ROI focused or return focused, but not obsessed. We still are creators. We still love our craft. We still want to kind of create things which are great. And that is where the leaders have to balance it out, whether it is 70-30, 50-50, 60-40, whatever it is, right? And then very important benefits, identify KPIs which are closer to money. I think I've said it too many times now. But force your teams to think like that. Comprehensive measurement. I think a lot of teams do comprehensive measurement, at least I've found, but not on the right KPIs. That is the thing. Cost, important to understand costs, because only once we understand them, calculate them, we can optimize them. Before that, it doesn't come to our mind. Once you do it again and again, it develops into a culture. It becomes hygiene. Your team basically stands out in terms of saying what they produce as business value and kind of gain ground in the organization. And it makes our work trustworthy. Like if we scrutinize ourselves to that extent, everybody would trust us. Yeah, that's it.